Hello, hello. I am back again. So let's talk about question number 4 about the arm. Okay, let me pull up this Excel file. Again, in question number 4 in the homework. Okay, so this is an arm for 100,000. It's made at a time when the expected start rate is 5%. Okay, loan will be made with a teaser rate of 2% in the first year. And is fully amortized and has a maturity of 25 years remaining, and payments will be made monthly. So question A asks you, what will be the payment during the first year? So again, I'm going to lay out everything as if it's in a calculator layout because I don't expect you to use Excel, of course, during the exam. So in the first year, at the beginning of the first year, the remaining number of payment is basically 300. Okay, 300 times which is equal to 25 times 12. Okay, now the uh, the initial rate, the teaser rate in the first year is 2%. So we put that in with the outstanding balance of 100,000. Future value amortized, fully amortized, equal to 0 at the end of 25 years. We're going to have the payment for the first year, 423.85. Then the next line, we are going to calculate at the end of the first year with the remaining number of payments, 288 payments waiting for us in the following 24 years. Then we're going to have, we'll pretend as if it's still the teaser rate to calculate the outstanding balance. So here I made a little change just to show the difference, just trying to differentiate. In reality, it doesn't really matter which one is positive and which one is negative. Okay, so here in this one, I'm trying to show that this is at the end of the year and put it into a different sign. So it's just easier to differentiate. At the end of the year balance, then given the payment equal to 423.85, we're going to calculate the present value or balance outstanding is 96,884.31. Then the third step is to look at the beginning of the second year using the previous balance outstanding. Okay, remember this is not a plan, so the balance outstanding is not going to change. For a plan, a balance outstanding will be adjusted for inflation, but here this is on. So interest rate is adjusted. Interest rate is adjusted from 2% to the 6%, which is the reset rate given in Part B. Okay, then we're going to calculate the new payment, which turned out to be 635.54. So that will be the answer of the Part B, 635.54. Okay, in Part C, it asks you by what percentage will the monthly payment increases. So we're basically comparing the beginning of second year payment to the first year payment. So we're comparing 635.54 to 423.85 and see how much of a percentage increment there will be. So we take 635.54 divided by 423.85 and minus 1. So 49.943% is the incremental percentage. For Part D, then, what if the reset date is 3 years later? Well, then the question becomes the same template, except for instead of adjusting, instead of looking at the end of the first year and putting the number of outstanding payments as 288, we are going to instead look at the end of year 3, okay, and then the remaining balance remaining number of payments will be 264, which is 300 minus the 3 years payments 36 payments, right? You have 264 left. So with that in mind, with the still in the first 3 years, if it's the first reset is after 3 years, then the first 3 years will all be the teaser rate of 2%. Then you're going to use the same payment to calculate the outstanding balance, which now becomes 90465.10. Okay. And at the beginning of next year, which is at the beginning of year 4, then we are going to use the same 90465.10 as the outstanding balance, and then calculate the new payment with the new interest rate. Okay, so again, this interest rate is new and the outstanding balance is not adjusted for ARM. And then the payment is now 617.94, which is the answer for part D. Okay, have you got it?